Okay, so this is another video on section 6.1. In this one, we're going to focus on applications and one type of application in particular, because it's the one that tends to confuse students the most, and it's what's called bearing. And you use it a lot. Again, if you've ever used a compass, you talk about bearing and all that. And there is a certain way you have to set up the problems in order to solve them, and you have to understand how bearing works to do it, which is why I wanted to go over this. And the idea is, so far when we have done things with triangles and angles, and we plot them in the plane, we generally plot them in terms of acute angles from the horizontal, reference angles. So say I might have a 30-degree angle right here, or maybe I have a reference angle over here of 35 degrees. And the angles I create are from the horizontal. The one difference, the major difference when it comes to bearing, is that bearing isn't based off of the horizontal, it's based off of north-south and your difference from north and south, your difference from the vertical. So maybe now, the way we write things, we could say something like north, 30 degrees east. What that means is start with the vertical, and then go 30 degrees east. East is this way, so I do that, and that angle is 30 degrees. The angle from the vertical, not the horizontal. If we're thinking about this in terms of the trigonometry we've done before, we would use this reference angle, which would be 60 degrees. 30 degrees is the bearing. So you just have to keep that straight and make sure you're writing your answers correctly. One of the biggest issues students have solving these problems is to sketch everything out correctly, do all their complex trig correct, and then not write out your answer correctly using the correct bearing notation and find the correct angle. The angle from the vertical, not the horizontal. Just one or two really quickly before we solve a problem to make sure we're clear. If my bearing is south, 23 degrees west, that means I start by going down, and then I go 23 degrees west. West is to the left, and that angle from the vertical is 23 degrees. If I have north, 18 degrees west, I start going north. 18 degrees west means go left. And this angle from the vertical is 18 degrees. Good. Now to actually put this in practice, we'll solve a problem. And I have these written down to make sure we have nice problems. So let's see. A plane flies at 320 knots for 1.2 hours, bearing south 32 degrees west. Find how far it went, both in the southern direction and the western direction. Okay. If that question seems a little odd, sketch out what you're doing and then it'll actually make a lot more sense. So let's see. Draw my axis. I fly at 320 knots for 1.2 hours, bearing south 32 degrees west, which means I go south, 32 degrees west means I go left, so I'm right over here. This angle is 32 degrees. Now, when I say how far did I go in both the southern direction and the western direction, essentially the idea is I'm traveling diagonally, but essentially I'm traveling part of the way to the west and part of the way to the south. And when you combine both of those, then you actually get my distance traveled diagonally. So I'm really looking for how far I go horizontally and how far I go vertically. How you choose to set these up is entirely up to you. I want to say your book might actually use a triangle down here. I tend to prefer using a triangle over here. It doesn't matter, it's entirely up to you. As long as you can draw a right triangle, you can use your right triangle trigonometry. Like I said, since I prefer this one, we're going to go over here. If I draw a right angle right here, draw my right triangle, that's 32 degrees, This is a right angle right here, which means if this one is 32 degrees, this one has to be 90 minus 32, which is 58 degrees. What other information do we have? Well, let's see. This line tells me that my direction of travel and how far I traveled. I traveled 320 knots for 1.2 hours. 320 knots just means nautical miles per hour, so it's like miles per hour. So basically, I traveled 320 miles per hour for 1.2 hours. How far did I travel? Pull out your calculator. 320 knots times 1.2 hours, 384 miles. So this distance is 384 miles. And now, what am I looking for? I want to know this distance right here, call it x, and this distance right here, call it y. How far I travel in the x direction and the y direction. But we can just use what we did last time. We have this angle, 58 degrees. We have the hypotenuse. We want to find those two sides. So use my right triangle trigonometry. Let's see, in terms of this one right here, x is adjacent, that's hypotenuse, so that's cosine. Cosine of 58 degrees equals adjacent x over hypotenuse 384. To solve for x, multiply 384. So 384 cosine 58 degrees equals x. Throw it into your calculator. Cosine 58 times 384. And we get 203.5. So x is apparently 203.5 miles. Do the same with y. Let's see, in terms of this angle, y is opposite, 384 is adjacent, so that's sine. So sine of 58 degrees equals y over hypotenuse, 384. Multiply the 384 again, and y is 384 times sine of 58 degrees. And let's see what we get. 384 times sine of 58. 325. So y is apparently 325 miles. And there we go. I traveled 384 miles diagonally, which essentially means I traveled 203 miles west and 325 miles south. Now that we are solving word problems, you want to make sure that your answers make sense once you solve a problem. Since a lot of your work will be punching buttons into a calculator and hitting enter, you want to make sure you didn't just hit the wrong button. So think about it. My angle is 58 degrees here, which means I'm traveling further. My angle is steeper, which means the y value should be greater than the x value. We've mentioned before, if you have a 45-degree angle, x and y are equal. Since this is bigger than 45, it means the y should be bigger than the x, which is exactly what we got. Both of them are smaller than the hypotenuse, so everything seems to work out and make sense. That's a good thing. We're going to solve one more, and then we'll be good. So let's see. A boat leaves the marina. Traveling north 52 degrees east at 6 miles per hour for 1 hour. It turns 90 degrees counterclockwise for 2 hours. At the new bearing north 38 degrees west. Let's see. Find its distance to the marina, or I guess from the marina, and find its bearing. kind of a long, involved type problem. So set it up, draw a picture to get an idea of what's going on. Let's see. A boat leaves the marina traveling north 52 degrees east, which means I'm going up and to the right. So maybe like this, at 6 miles per hour. This is a 52-degree angle, since that's my bearing from the vertical. And I travel at 6 miles per hour for 1 hour, which means I travel 6 miles. That's easy enough. I turn 90 degrees counterclockwise, which basically means counterclockwise is this way. I go 90 degrees over here. This new bearing, if we want to draw it out, is north 38 degrees west, which means this angle right here is 38 degrees west. I do that for 2 hours at the same speed, which means this side, 6 miles per hour for 2 hours, is 12 miles. I now want to find my distance from the marina. I can't draw straight, so pretend. I want to find that distance, which is that side right there, and I want to find my bearing, which is actually my bearing from here, or from here right here, my bearing from the marina. We'll just find this bearing right here. One thing I will mention, because it came up in class, how do I know that when I travel 6 miles this direction and 12 miles that direction, this ends up being over in the second quadrant as opposed to somewhere up here in the first quadrant? Ultimately, outside of practice, I don't. I just kind of use this picture as a guide and I let the problem itself work out my solution. If somehow I get a solution that doesn't necessarily make sense, that would tell me maybe my picture is wrong and I should have actually had the bearing over here. That will work itself out again. This picture is not set in stone. It's a guide to help us understand what's going on. So really quickly, I want to find my distance right here. Well, I just drew a right triangle. So my distance is just the hypotenuse. So what's my distance? Well, let's see. It's 12 squared, which is 144, plus 6 squared, which is 36. That's c squared. That is 180 is c squared. So c is the square root of 180, which is 13.4. So this distance is 13.4. Now I want to find my bearing. There are different ways to do this. One thing you can do, and again, it's a little hard to see here. I can maybe make it bigger over here. Essentially what I have is a line going here, then a line going there, and then I come back here. I want to make it nice and big so you can see it. A line going here, a line going there. There we go, I'll make it even bigger. I want to find my bearing. My bearing is this angle right here, which is small, but this is still a right triangle. So in theory, what I can do is find this whole angle. It's just an angle in my triangle. And then I know from over here that this part of the angle is 52 degrees. So whatever angle this turns out to be, subtract 52 from it, and that has to be that part right there, which is my bearing. So, really quickly, what are my trig functions? Let's see, I have these sides.